सबै छात्र छात्रावर्गलाई मेरो तर्फबाट नमस्कार। त आज विशेष गरेर म क्लास 12 को विद्यार्थीहरूलाई कन्टिन्युटी अनि डिफरेन्सिबिलिटी बारे पढाउन गइरहेको छु। त लास्ट अनलाइन क्लासमा पनि हामीले यही टपिक नै गरेका थियौं अनि त्यतिबेला हामीले धेरै प्रब्लमहरु पनि गर्यौं। त आज पनि म तिमीहरुलाई त्यही प्रब्लमहरु नै देखाउने छु। त यो कन्टिन्युटी एन्ड डिफरेन्सिबिलिटी को प्रब्लमहरु कसरी गर्दैछौं हामीले सायद तिमीलाई अहिलेसम्म थाहा भइसकेको हुनुपर्छ, किनभने तिमीले घरमा यो प्र्याक्टिस गर्नै पर्छ। सो आई थिंक you know the method how to examine whether the given function f of x is continuous or not at a given point, and how to find out or how to examine whether the given function f of x is differentiable or not at a given point. त अहिलेसम्म यी कुराहरु चाहिँ तिमीलाई थाहा भइसकेको हुनुपर्छ, ठीक छ। त कुनै पनि एउटा फंक्सन दिएको छ, कुनै पनि एउटा फंक्सन अफ x दिएको छ, त त्यो फंक्सन अफ x कन्टिन्युअस हुन्छ कि डिफरेन्सिएबल हुन्छ एट अ गिवन पॉइंट, त्यो तिमीले कसरी चेक गर्नुपर्छ, त्यो मेथड तिमीले सबैलाई त्यो मेथड I think you know that method, how to get that, how to examine that whether the given function f of x is continuous or not at a given point, and how to examine whether the given function f of x is differentiable or not at the given point. X is equal to some constant, that is x is equal to a, something like that, where a is any real number in this case. Okay, so now here continuity and differentiability. So let us start the same exercise, that is exercise 2b. Section is 5 marks section, page number 266. So let us start this question number 3. त हामीले लास्ट अनलाइन क्लासमा क्वेशन नम्बर 2 गरेका थियौं। त आज हामी क्वेशन नम्बर 3 गर्ने छौं। त क्वेशन नम्बर 3 मा के भन्दैछ भन्दाखेरि ए फंक्शन f of x is defined as follows. त यो फंक्शन अफ x चाहिँ कसरी डिफाइन गरेको छ, कसरी यसको परिभाषा लेखिएको छ भन्दाखेरि f of x is equal to 1 minus x when x less than 1. यदि x less than 1 छ भने f of x को भ्यालु कति हो, 1 minus x. यदि x greater than or equal to 1 छ भने f of x is equal to x square minus 3x plus 2. यहाँ दुईटै रिलेसन छ, ग्रेटर देन रिलेसन पनि छ, इज इक्वल टु 1 रिलेसन पनि छ। x ग्रेटर देन 1 भयो भने पनि, x is equal to 1 भयो भने पनि f of x is equal to कति छ, x square minus 3x plus 2. Now you have to examine the differentiability of the function f of x at x is equal to 1. Whether it is differentiable or not at x is equal to 1, you have to check it. Okay? And hence you have to state whether the function f of x is continuous or not at the point x is equal to 1. So first of all, you have to check the differentiability of the function at x is equal to 1. If the function f of x is differentiable at x is equal to 1, then obviously that function f of x is continuous at x is equal to 1. Otherwise, if the function f of x is not differentiable at x is equal to 1, then the function may or may not be continuous at x is equal to 1. Okay, but if the function is differentiable at x is equal to 1, then it should be obviously continuous at x is equal to 1. But if the function is not differentiable at x is equal to 1, the function may or may not be continuous at x is equal to 1. Is that clear? So now let us examine the differentiability of the function f of x at x is equal to 1. So for this you have to find out both right hand derivative and left hand derivative. Okay, so for right hand derivative, so what is the definition of right hand derivative now? For right hand derivative, what is the definition? Capital R f dash of x is equal to limit h tends to 0 plus f of x plus h minus f of x, this whole divided by h, right? But since we are checking the differentiability of the function f of x at x is equal to 1, you put x is equal to 1 in this case. So putting putting x is equal to 1. So what do we get now? Capital R f dash of 1 is equal to limit h tends to 0 plus f of, this is your 1 plus h minus f of 1 whole divided by h. Is that clear now? So h tends to 0 plus भनेको h greater than 0. Okay? So your rough part ma हामीले के लेख्यौ h greater than 0. Now since you have to get the value for f of 1 plus h, you add 1 on both the sides. Okay? But you have to get the value for f of 1 plus h. So you add 1 on both the sides. So what do we get? 1 plus h greater than 1. Right? So now instead of 1 plus h, you write x. So it will be x greater than 1, isn't it? So in the given question, what is the value for f of x when x greater than 1? The x greater than 1 हुँदाखेरि f of x को value कति छ? x square minus 3x plus 2. That is f of x is equal to कति रहेछ? x square minus 3x plus 2. x square minus 3x plus 2, right? So now you put x is equal to 1 plus h because you have to get the value for f of 1 plus x. Now we put 1 plus h instead of x. 1 plus h is equal to 1 plus h whole square minus 3 into 1 plus h, then it is plus 2. So we have got the value for f of 1 plus h, right? So let us put the value here is equal to limit h tends to 0 plus, what is f of 1 plus h? This is 1 plus h whole square minus 3 into 1 plus h, then plus 2 minus. Now what is the value for f of 1? Can you tell me what is f of 1? f of 1 भनेको के हो? The value of the function f of x when x exactly equal to 1. यो f of 1 भनेको त्यो f of x को भ्यालु हो जब x is equal to 1 हुन्छ. So जब x is equal to 1 हुन्छ, what is the value for f of x? x is equal to 1 त यहाँ हुँदैछ. x is equal to 1 हुँदा नि f of x को भ्यालु कति छ? x square minus 3x plus 2. त x को जम्मा 1 हाल्दा के भयो? f of 1 is equal to 1 whole square minus 3 into 1 plus 2. Is that clear now? So we can write here within second bracket instead of x you have to put 1 because this is exactly x equal to 1 out here. So it is 1 whole square minus 3 into 1, then it is plus 2. Second bracket closed. This whole divided by h. So I think you have understood it. You can copy it. So यो चाहिँ तिमीले रफ पार्टमै कपी हो नि ल. त्यो खाताको दाहिनेतिर चाहिँ तिमीले यो सार्नु. ठीक छ? यो सार्यो भने चाहिँ तिमीले बुझ्छौ. So I think you have understood it. Rough work पार्ट पनि तिमीले कपी गर्यौ. तिमीले बुझ्यौ पनि होला सायद, हैन? So now let us simplify it further now. So म यो मेटाउँदै छु अब. अब हामी यसलाई सिम्प्लिफाई गर्दै लान्छौं. So which is equal to limit h tends to 0 plus. Now let us simplify 1 plus h whole square. This is your a plus b whole square. 1 plus 2h plus h square, right? Now multiply by minus 3 here. Minus 3 minus 3h. Minus 3 minus 3h plus 2. Plus 2 minus within bracket 1 minus 3 plus 2. 1 minus 3 plus 2. Is that clear now? This is 1 minus 3 plus 2 whole divided by h. This whole divided by h, right? So which is equal to limit, let us simplify it further, h tends to 0, this 2 plus 1, this 2 plus 1 is 3, right? Then this minus 2h, plus 2h minus 3h is minus h, then write down minus 3, then plus h square minus, this is 2 plus 1 is 3 minus 3 whole divided by h. Is that clear? So here you can cancel, this 3 gets cancels, this 3 gets cancels, which is equal to limit h tends to 0. So what is common out here? this is h minus 1. First you write positive term, h is common within bracket, h minus 1 divided by h. So h gets cancels. So which is equal to limit, actually h tends to 0 means this is 0 plus, h tends to 0 plus h tending to 0 from the right hand side. That means you can put h is equal to 0 in this case. So limit h tends to 0 plus, this is your h minus, which is equal to, now you can put h is equal to 0. So this is 0 minus 1, which is equal to minus 1. So this is your right hand derivative. You have understood? So we have got this right hand derivative. You can copy it. Now we will find out the left hand derivative now. So I think you have understood it. तिमीले सायद यो बुझ्यौ होला. अब हामी लेफ्ट ह्यान्ड डेरिभेटिभ गर्ने छौं. So let's do left hand derivative now. So for left hand derivative, so for left hand derivative, what is the definition of left hand derivative? Capital L f dash of x is equal to limit h tends to 0 minus f of x plus h minus f of x, this whole divided by h. Now since we are checking the differentiability of the function f of x at x is equal to 1, so you put x is equal to 1 in this case. So putting x is equal to 1. So therefore capital L f dash of 1 is equal to limit h tends to 0 minus f of, this is 1 plus h minus f of 1, this whole divided by h. Is that clear? So I think you have copied it. I am rubbing it now. Now in this case you have to get the value for f of 1 plus h and f of 1, right? That is function of 1 plus h. You have to get the value of function of 1 plus h when h tends to 0 minus. What is the meaning of h tends to 0 minus? H is approaching towards 0 from the left hand side. And on the left of 0, all the values of h are less than 0, isn't it? So h is less than 0 here. Now since you have to get the value for f of 1 plus h, you add 1 on both the sides. What do we get? 1 plus h less than 1. So now 1 plus h लाई हामी के लेख्छौं? x in x. So this is x less than 1. So now in the question, what is the value for f of x when x less than 1? When x is less than 1, what is the value for f of x? It is 1 minus x. So that is, we can write f of x is equal to 1 minus x. Now what is f of 1 plus h? Therefore f of 1 plus h is equal to 1 minus within bracket 1 plus h. So instead of x you have to write 1 plus h. So which is equal to, we can write it here now. So which is equal to limit h tends to 0. What is f of 1 plus h here? It is 1 minus within bracket 1 plus h. Is that clear now? So what is f of 1 here again? Minus, what is f of 1? F of 1 is out here. So instead of x you have to write 1. Instead of x, what you will write? 1. Okay? So here x is equal to 1 means f of x is equal to x square minus 3x plus 2. So here we can write 1 whole square minus 3 into 1 plus 2. I think you have understood it. X is equal to 1. So here f of x is equal to x square minus 3x plus 2. But you should put x is equal to 1 in this case. If you put 1 here, this will be 1 whole square minus 3 into 1 plus 2. Put this expression within second bracket. So whole divided by this one is your h. Is that clear? So now we have understood it. So let us simplify it. Which is equal to limit h tends to 0 minus Now simplify the numerator. 1 minus 1 minus into plus minus h, right? Minus within bracket 1 whole square is 1 minus 3 ones are 3 plus 2 whole divided by h. Is that clear to all of you? So we can cancel this. 1 gets cancels, which is equal to limit h tends to 0 minus, this is minus h minus, so this is 3 minus 3, that is your 0 whole divided by h, which is equal to limit h tends to 0 minus minus h by h. Here h's gets cancels, which is equal to limit h tends to 0 minus within bracket minus 1, which is equal to, now this minus 1 is constant, which is free from h. So what is the value of this limit? That is minus 1, because minus 1 is a constant quantity which is free from h. The h value 0 यहाँ हाल्नु पर्दैन. So what is the value of this limit? It is minus 1. So are they equal? What was the right hand limit? Oh sorry, what was the right hand derivative? Right hand derivative was minus 1. Left hand derivative is also minus 1. Since right hand derivative is equal to left hand derivative, there the function f of x is differentiable at x is equal to 1. Okay? त तिमीले यो कपी गर. त हामीले लेफ्ट ह्यान्ड डेरिभेटिभ पनि निकाल्यौं, राइट ह्यान्ड डेरिभेटिभ पनि निकाल्यौं, अनि दुईटाको भ्यालु सेम आएको छ, दैट इज -1, राइट? सो राइट ह्यान्ड डेरिभेटिभ इज इक्वल टु -1 and left hand derivative is also -1. That means they are equal. So you have to write here, since right hand derivative at x is equal to 1 is equal to left hand derivative at x is equal to 1. Therefore, the function f of x is differentiable at x is equal to 1. So you know a theorem, if the function f of x is differentiable at x is equal to 1, then it must be continuous at x is equal to 1. So we have proved this statement, that is the function f of x is differentiable at x is equal to 1. So this function f of x must be continuous at x is equal to 1. Therefore, the function f of x is continuous at x is equal to 1. So it is also done. So I think you have understood it. So you can copy it. We'll do the next question now. So now we'll do the next question, that is question number 4. If the function f of x defined below is differentiable at x is equal to 1, then find the values of p and q. So what is the given function of x here? F of x is equal to x square plus 3x plus p when x less than or equal to 1. X less than 1 हुँदा पनि यही function, x is equal to 1 हुँदा पनि यही function. ठीक छ? And but f of x is equal to qx plus 2 when x greater than 1. So when x is greater than 1, what is the value for f of x? It is qx plus 2. Now since it is given that the function f of x is differentiable at x is equal to 1, it should be continuous at x is equal to 1. Okay? Since the function f of x is differentiable at x is equal to 1, therefore the function f of x is continuous at x is equal to 1, right? Is that clear? So from theorem we know that if the function f of x is differentiable at x is equal to 1, then that function f of x should be continuous at x is equal to 1. So let us find out right hand limit, left hand limit and the value of the function at x is equal to 1. So for right hand limit at x is equal to 1. So first you calculate for right hand limit at x is equal to 1. What is meant by it? limit x tends to 1 plus f of x is equal to limit x tends to 1 plus, that is x is approaching towards 1 from the right hand side, and on the right of x is equal to 1 all the values of x are greater than 1. So what is the value for f of x when x greater than 1? When x greater than 1, what is the value for f of x? It is qx plus 2. So this is your qx plus 2, which is equal to, you put x is equal to 1 out here, it will be q into 1 plus 2, which is equal to q plus 2. So I think you have understood it. Now for left hand limit. For left hand limit, what do we write? Limit x tends to 1 minus f of x is equal to limit x tends to 1 minus. So what is the meaning of x tends to 1 minus? X is approaching towards 1 from the left hand side, and on the left of x is equal to 1 all the values of x are less than 1. So what is the value for f of x when x less than 1? When x is less than 1, then f of x is equal to x square plus 3x plus p, right? So right here x square plus 3x plus p, which is equal to, now x tends to 1 minus means you can put x is equal to 1 in this case. So it is 1 whole square plus 3 into 1 plus p, which is equal to, this is your p plus 4. Is that clear to all of you? So we have got both right hand limit as well as left hand limit. Now at x exactly equal to 1, what is the value for f of x when x exactly equal to 1? It is x square plus 3x plus p. So you can write here f of x is equal to x square plus 3x plus p. So you put x is equal to 1 in this case. So therefore f of 1 is equal to 1 whole square plus 3 into 1 plus p. Or this is f of 1 is equal to, this is your 4 plus p. So we have got the value for f of 1, which is equal to 4 plus p. So I think you have understood it. So since f of x is continuous as at x is equal to 1, since f of x is continuous at x is equal to 1, so what can you write? Right hand limit at x is equal to 1 is equal to left hand limit at x is equal to 1 is equal to f of 1, right? So therefore limit x tends to 1 plus f of x, that is your right hand limit, is equal to limit x tends to 1 minus f of x, that is your left hand limit, is equal to f of 1, is equal to, this is your f of 1, right? So or what is limit x tends to 1 plus f of x? This is your q plus 2, which is equal to, what is limit x tends to 1 minus f of x? That is your left hand limit, its value is p plus 4, which is equal to, what is f of 1? It is 4 plus p. So these two are same. Either you can equate first is equal to second or first is equal to third. So q plus 2 is equal to p plus 4, or q minus p is equal to, what is here? This is 2. So let us mark it number 1. So we have got one of the relations out here between p and q, that is q minus p is equal to 2. That is q minus p is equal to 2. Let us write it here in the rough part. Okay. So now since the function f of x is differentiable at x is equal to 1, so you have to find out both left hand derivative and right hand derivative. You have to find out both left hand derivative and right hand derivative, right? And both of these left hand derivative and the right hand derivative must be equal. So now first of all, let us find out the left hand derivative. Okay, so for left hand derivative, let us find out left hand derivative. So what is the definition of left hand derivative? What is the meaning of left hand derivative? It is L f dash of x is equal to limit h tends to 0 minus f of x plus h minus f of x, this whole divided by h, right? Now since we are checking the differentiability of f of x at x is equal to 1, so we put x is equal to 1 in this case. So putting x is equal to 1. So capital L f dash of 1 is equal to limit h tends to 0 minus f of, instead of x you write 1 plus h minus f of 1 whole divided by h, right? So now what is the value for f of 1 plus h? So how can you put the value for f of 1 plus h in this case? So since h tends to 0 minus is given, h tends to 0 minus vaneko h is less than 0, right? But since we have to get the value for f of 1 plus h is there, so you add 1 on both the sides, that is 1 plus h less than 1. So let us take this 1 plus h as x, so it is x less than 1. So when x is less than 1, what is the value for f of x? It is x square plus 3x plus p, right? So it is f of x is equal to x square plus 3x plus p. Now instead of x you can put 1 plus h, right? The x को जग्गामा अब हामी के हाल्न सक्छौं 1 plus h हाल्न सक्छौं, so that we can get the value for f of 1 plus h. So your of my f of 1 plus h is equal to 1 plus h whole square plus, this is the continuation part, 1 plus h plus p. Is that clear? So let us write it out here. So which is equal to limit h tends to 0 minus, what is f of 1 plus h? It is 1 plus h whole square plus 3 into 1 plus h plus p minus, what is f of 1 now? F of 1 means the value for f of x when x exactly equal to 1. When you put x is equal to 1 here, this will be 1 square plus 3 into 1 plus p. So this will be 1 whole square plus 3 into 1 plus p. Second bracket is closed, whole divided by h. So you can copy it. You can copy it in the rough part. यसलाई rough part मा तिमीले copy गर्ने यो, because you have to understand it. Okay. So if you can understand it, then you can easily put the value for f of 1 plus h in this case. Okay. So you can copy it. Now we'll do the further simplification. So let us simplify it now. So I am rubbing it. So in the next step, you write down limit h tends to 0 minus, let us simplify it. What is 1 plus h whole square? A plus b whole square, 1 plus 2h plus h square, right? Then plus 3 plus 3h. 1 plus h is multiplied by 3. So it is 3 ones are 3 plus 3 into h 3h plus p minus within bracket 1 square is 1 plus 3 is 4 plus p, right? Whole divided by h. Is that clear? So let us simplify it further, which is equal to limit h tends to 0 minus. So 1 plus 3 is 4 plus 2h plus 3h is 5h. Then plus h square plus p minus 4 minus into plus minus p whole divided by h. So you can cancel here, 4 gets cancels and here pp gets cancels, which is equal to limit h tends to 0 minus, what is common in the numerator, that is h is taken common. So within bracket we have 5 plus h divided by h. Here also h gets cancels. So which is equal to limit h tends to 0 minus within bracket 5 plus h. So we can put h is equal to 0 out here. Okay. So if you put h is equal to 0, 5 plus 0, which is equal to 5. That means, what is the left hand derivative? The left hand derivative is 5 out here. Is that clear? So now we'll find out the right hand derivative now. So this is your left hand derivative. So let us find out the right hand derivative. So I think you have understood this left hand derivative. So let us find out the right hand derivative. Okay, so let us find out for right hand derivative. So for right hand derivative, what can you write? Its definition is capital R f dash of x is equal to limit h tends to 0 plus f of x plus h minus f of x, this whole divided by h, right? So now you can put x is equal to 1 here because we are checking the differentiability of the function at x is equal to 1. So you put x is equal to 1 here. So putting x is equal to 1. So therefore capital R f dash of 1 is equal to limit h tends to 0 plus f of 1 plus h minus f of 1 whole divided by h. Now in this case, how can you get the value for f of 1 plus h now here? यो f of 1 plus h को value हामी कसरी निकाल्छौं यहाँ? So how can you get it? H tends to 0 plus means h is approaching towards 0 from the right hand side, and on the right of h is equal to 0, h is always greater than 0. So we can write here h greater than 0. Since we have to get the value for f of 1 plus h, you add 1 on both the sides. So it is 1 plus h greater than 1. So let us take this 1 plus h as x. So it will be x greater than 1. When x is greater than 1, what is the value for f of x? F of x is equal to qx plus 2. Right? Put 1 plus h instead of x. 1 plus h is equal to q into 1 plus h plus 2. Is that clear now? So this is the rough work, right? So let us put the value here. Therefore capital R f dash of 1 is equal to limit h tends to 0 plus, right? This is h tends to 0 plus. What is f of 1 plus h? This is q into 1 plus h then plus 2, right? Minus, now within second bracket, what is the value for f of 1? What is f of 1 actually? The value for f of x when x exactly equal to 1. When x is equal to 1, what is the value for f of x? X square plus 3x plus p. Put x is equal to 1, what do we get? 1 whole square plus 3 into 1 plus p. So it is 1 whole square plus 3 into 1 plus p. Is that clear? So whole divided by, you can write here h. So I think you have understood it. So you have copied it, I think. So I am rubbing it, this one, right? So now let us simplify it further. So right hand side, which is equal to limit, this is your right hand limit, limit h tends to 0 plus, simplify it. Q into 1 is q plus qh plus 2 minus within bracket. So it will be 1 plus 3, 4, 4 plus p. 4 plus p whole divided by h. Is that clear? Which is equal to limit h tends to 0 plus q plus qh plus 2 minus 4 minus p whole divided by h, right? So now in the next step is equal to limit h tends to 0 plus. So you write q minus p together here. This q minus p, then you write plus qh plus 2 minus 4 is minus 2 whole divided by h. Is that clear? So now what was the value for q minus p from 1 in the previous case? That is, since the function f of x is continuous at x is equal to 1, we got the relation out there. The relation was q minus p is equal to 2. So instead of q minus p, you can put 2 here. So is equal to limit, this is h tends to 0 plus, it is 2 plus qh minus 2 whole divided by h. Is that clear? So here 2 gets cancels, which is equal to limit h tends to 0 plus. Now this is qh by h. Here also hh gets cancels. So which is equal to limit h tends to 0 within bracket, this is only q. So now this q is constant because it is free from h. So in this case, you don't have to put the value for h, which is equal to 0. So simply the value of this limit is q. That is, your right hand derivative is q. Is that understood? So now you know that since the function f of x is continuous, that is, since the function f of x is differentiable at x is equal to 1, so right hand derivative is equal to left hand derivative, right? So let us write here, since f of x, so you can write, since f of x is differentiable at x is equal to 1, therefore right hand derivative at x is equal to 1 is equal to left hand derivative at x is equal to 1, right? So let us write here, since f of x is differentiable at x is equal to 1, so therefore what do we write? Limit x tends to 1 plus f of, this is r f dash of 1 is equal to l f dash of 1. That is, since f of x is differentiable at x is equal to 1, so right hand derivative at x is equal to 1 is equal to left hand derivative at x is equal to 1, right? So what is the right hand derivative at x is equal to 1? This is your right hand derivative, isn't it? So what is this value? It is q is equal to, what was the left hand derivative? Left hand derivative was 5. So q is equal to 5. We have got q is equal to 5. Now let us find out the value for p. So where will you put this value of q? You can put the value of q in number 1. So in the previous step, we have marked that equation, that is q minus p is equal to 2 as 1. So putting the value of q in 1. Putting the value of q in 1, right? So therefore, that is q minus p is equal to 2. This is equation 1. Or 5 minus p is equal to 2. Or what do we get? Or minus p is equal to 2 minus 5. Now 5 is taken to the right hand side, becomes minus 5. Or minus p is equal to minus 3. Minus minus gets cancelled. So p is equal to what? It is 3, right? So now we can write down the answers. So therefore p is equal to 3. And what is the value for q? Q is equal to 5. So these are the answers. So I think you have understood it. So q is equal to 3 and p is equal to 3 and q is equal to 5. So these are the answers. So I think you have understood it. So you can copy it. We'll do the next question now. So now we'll do the next question, that is question number 5. If the function f of x is equal to 2x plus 3 when x less than or equal to 1. When x less than 1, you have to use the function f of x is equal to 2x plus 3. When x is equal to 1, you have to use the function f of x is equal to 2x plus 3. Okay? For x less than 1 and x is equal to 1, you have to use the same function f of x is equal to 2x plus 3. But when x is greater than 1, what is the value for f of x? It is ax square plus bx. And this function of x is differentiable everywhere. That means if the function is differentiable everywhere, then this function f of x is differentiable at x is equal to 1 also. And you have to show that f dash of 3 is equal to minus 10. Okay? Now since the function f of x is differentiable everywhere, right? So therefore the function f of x is differentiable at x is equal to 1. So since the function f of x is differentiable at x is equal to 1, the function f of x must be continuous at x is equal to 1. Therefore, the function f of x is continuous is continuous at x is equal to 1, because we know a theorem: if the function f of x is differentiable at a point, then the function f of x must be continuous at that point. Okay, so now let us find out the right hand limit, left hand limit, and the value of the function at x is equal to 1. Okay, so for right hand limit, what do we write? Limit x tends to 1 plus f of x is equal to limit x tends to 1 plus. So x tends to 1 plus means x is approaching towards 1 from the right hand side, and on the right of x is equal to 1, all the values of x are greater than 1. So what is the value for f of x when x is greater than 1? When x is greater than 1, then f of x is equal to ax square plus bx. So it is ax square plus bx. So which is equal to a into, you put x is equal to 1 whole square, plus b into 1, which is equal to a plus b. I think you have understood it. This is your right hand limit, which is equal to a plus b. Now find out left hand limit. For left hand limit, what can you write? Limit x tends to 1 minus f of x is equal to limit x tends to 1 minus, limit x tends to 1 minus. What is the meaning of x tends to 1 minus? X is approaching towards 1 from the left hand side, and on the left of x is equal to 1, all the values of x are less than 1. So what is the value for f of x when x less than 1? When x is less than 1, what is the value for f of x? It is 2x plus 3. So it is 2x plus 3, right? So you can put x is equal to 1. X tends to 1 minus means x, you can put x is equal to 1 out here. So 2 into 1 plus 3, which is equal to 5. So this is your left hand limit. Now again at x is equal to 1. Now at x is equal to 1, that is, what is the value for f of x when x exactly equal to 1? So when x is equal to 1, then what is f of x? It is 2x plus 3. So therefore f of x is equal to 2x plus 3. So you put x is equal to 1 here. F of 1 into f of 1 is equal to 2 into 1 plus 3, which is equal to, this is also 5, right? Now since f of x is continuous at x is equal to 1, so we can write down right hand limit at x is equal to 1 is equal to left hand limit at x is equal to 1, which is equal to f of 1, isn't it? Since f of x is continuous, at x is equal to 1, so therefore right hand limit at x is equal to 1 is equal to left hand limit at x is equal to 1 is equal to f of 1, right? So since limit x tends to 1 plus f of x is equal to limit x tends to 1 minus f of x is equal to f of 1, right? So, or what can you write? So what is the value of the right hand limit? It is a plus b. A plus b is equal to, what is the left hand limit now? It is 5, which is equal to, what is the value for f of 1? That is also 5. So we can equate either first is equal to second or first is equal to third. That is a plus b is equal to 5. Suppose this is number 1, right? So let us write it here. That is a plus b is equal to 5, which is equation number 1. So we got this relation from the definition of continuity. Okay. Now since the function f of x is differentiable at x is equal to 1, you have to find out the right hand derivative at x is equal to 1 and left hand derivative at x is equal to 1. So let us find it now. Now for right hand derivative, so what can you write for right hand derivative? Capital R f dash of x is equal to limit h tends to 0 plus f of x plus h minus f of x, this whole divided by h. So let us find out this right hand derivative. Okay. So now since we are checking the differentiability at x is equal to 1, you put x is equal to 1 here. So putting x is equal to 1. So therefore capital R f dash of 1 is equal to limit h tends to 0 plus. It is f of 1 plus h minus f of 1 whole divided by h. Right? So what is the value for f of 1 plus h? 1 plus h. What is the value for f of 1 plus h when h tends to 0 plus? H tends to 0 plus means h is greater than 0. Since we have to get the value for f of 1 plus h, add 1 on both the sides. 1 plus h greater than 1. Right? And now for 1 plus h, we can take it as x. X greater than 1. So what is the value for f of x when x greater than 1? It is f of x is equal to ax square plus bx. Now instead of x, what should you put? 1 plus h. So this will be f of 1 plus h is equal to a into 1 plus h whole square plus b into 1 plus h, right? So you should understand this rough part. Okay, so what is the value for f of 1 plus h? It is, instead of x, you put 1 plus h, a into 1 plus h whole square plus b into 1 plus h, right? So let us write it here, which is equal to limit h tends to 0 plus. What is f of 1 plus h? It is a into 1 plus h whole square plus b into 1 plus h, right? Minus now what is f of 1? F of 1 means the value for f of x when x exactly equal to 1. When x exactly equal to 1, what is the value for f of x? It is 2x plus 3. So you can put here x is equal to 1 here. Okay. So 2 into 1 plus 3. So whole divided by, this is your h. Is that clear? So let us simplify it further, which is equal to limit h tends to 0 plus, right? Let us simplify it. A into 1 plus 2h plus h square. This is your a plus b whole square. Now multiply by b here, b plus bh minus, this is your 5 whole divided by h. Clear? Now now multiply by a is equal to limit h tends to 0 plus. So it is a plus 2ah plus h square plus b plus bh minus 5 whole divided by h, right? So let's simplify it further now. So let us simplify it further now, which is equal to limit h tends to 0, limit h tends to 0 plus. We're getting the value for right hand derivative. So now a plus b minus 5. So a plus b, write it together, then plus 2ah plus h square, right? Plus 2h plus h square, a plus b is written out there, then write down plus bh, then you have to write minus 5 whole divided by h. Okay, now what is a plus b in this case? Is equal to limit h tends to 0 plus, here a plus b is 5 plus, what is common here? H within bracket, 2a plus ah plus b bracket close minus 5 whole divided by h, right? So here 5 gets cancels, can cancel them, which is equal to limit h tends to 0, h within bracket 2a plus ah plus b whole divided by h. Here also h's gets cancels. So which is equal to limit h tends to 0, it is 2a plus ah plus b. Now we can put h is equal to 0 in this case. H tends to 0, actually it is plus. H tends to 0 plus when h is approaching towards 0 from the right hand side, but here you can put the value for h, which is equal to 0. So if you put h is equal to 0, what do we get? Which is equal to 2a plus b. Is that clear? So this is your right hand derivative. I think you have understood it. So this is your right hand derivative. Okay. Now let us find out the left hand derivative. So let us find out the left hand derivative now. So how can you find out the left hand derivative now? तो अब हामी left hand derivative निकाल्दै छौं. For left hand derivative, for left hand derivative. So how will you write down the left hand derivative? Capital L f dash of x is equal to limit h tends to 0 minus f of x plus h minus f of x whole divided by h. Since we are checking the differentiability at x is equal to 1, so we put x is equal to 1 in this case. So putting x is equal to 1. So therefore capital L f dash of 1 is equal to limit h tends to 0 minus. So f of this is your 1 plus h minus f of 1 whole divided by h, right? So now therefore capital L f dash of 1 is equal to limit h tends to 0 minus. So now what is the value for f of 1 plus h? When h tends to 0 minus, h tends to 0 minus means h is less than 0. Since you have to get the value for f of 1 plus h, you add 1 on both the sides. So 1 plus h less than 1. So let us take this 1 plus h as x, which is x less than 1. So what is the value for f of x when x less than 1? It is 2x plus 3. So f of x is equal to 2x plus 3. That is f of 1 plus h is equal to 2 into 1 plus h plus 3, right? So this is the rough work. So what is the value for f of 1 plus h in this case? 2 into instead of x you put 1 plus h, then plus 3. So it is 2 into 1 plus h plus 3 minus what is f of 1? What is f of 1 in this case? When x is equal to 1, f of x is equal to x plus 3. You put x is equal to 1 out here. So it is 2 into 1 plus 3. So it is 2 into 1 plus 3. So whole divided by h. Now let us simplify it, which is equal to limit h tends to 0 minus. Now it is 2 plus 2h plus 3 minus 5 whole divided by h. 2 plus 3 is 5. 5 gets cancels. 2 plus 3 is 5. 5 minus 5 gets cancels. Right? So now next, 2h by h, which is equal to limit h tends to 0 minus. Limit h tends to 0 minus. So it is 2h upon h. It is 2h divided by h. Right? 2h divided by h. So what is 2h divided by h? Here h gets cancels. So which is equal to limit h tends to 0 minus. So this is only 2. Since this is free from h, so this 2 is a constant quantity. What is the limiting value of this expression? Which is equal to 2. So now just now we got the value for right hand derivative, isn't it? What was right hand derivative? So what was the right hand derivative here? The right hand derivative here was, so right hand derivative was I think 2a plus b. You can check it. You can pause the video or you can repeat the video. Okay. So in the previous step, we have found out the right hand derivative as it was 2a plus b. Okay, the right hand derivative was 2a plus b. And what is the left hand derivative? It is 2. Clear? So now since the function f of x is differentiable at x is equal to 1, so right hand derivative at x is equal to 1 is equal to left hand derivative at x is equal to 1. So let us write it. Since f of x is differentiable, at x is equal to 1, so therefore this is your left hand derivative. Capital A r f dash of 1 is equal to capital L f dash of 1, right? That is right hand derivative at x is equal to 1 is equal to left hand derivative at x is equal to 1. So what was the right hand derivative in this case at x is equal to 1? It was 2a plus b. So this is 2a plus b is equal to, what is the left hand derivative at x is equal to 1? That is your 2. And let us mark it as equation number 2. So equation 1 was a plus b is equal to 5, isn't it? So let us solve these two equations to get the values of a and b. So solving 1 and 2. So what is number 1 out here? A plus b is equal to 5. And what is number 2? It is 2a plus b is equal to 2. Let us solve it to get the values of a and b. So you can subtract it, minus, 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 bb gets cancelled. So it is a minus 2a is minus a is equal to 3. Or a is equal to, this is your minus 3. So let us get the value for b. Putting the value of a in 1. So number 1 here is a plus b is equal to 5, or minus 3 plus b is equal to 5. Now what is the value for b? B is equal to 8. So now we have to prove the value for f dash of 3. So f dash of 3 is equal to minus 10. Actually this 3 is more than 1. So what is the value for f of x when x greater than 1? Since you have to get the value for f dash of 3. So x is equal to 3 out here. This 3 is greater than 1. So you have to put, or you have to write f of x is equal to ax square plus bx. So let us write here f of x is equal to ax square plus bx. Since you have to get f dash of 3, so which function of x is used out here? Since this 3 is more than 1, if x is greater than 1, you have to use f of x is equal to ax square plus bx. That's why we write here f of x is equal to ax square plus bx. So let us put the value for a and b. Or f of x is equal to, what is the value for a? It is minus 3 3x square plus, what is b? It is 8x. Is that clear to all of you? So now let us differentiate it to get the value for f dash of x. So differentiating both the sides with respect to x. So this is f dash of x is equal to, now we can differentiate it. So it is minus 6x plus 8. You know how to differentiate it, isn't it? What is the differentiation of x square? It is 2x. What is the differentiation of x? It is 1. So if it is 2x, 2x into minus 3 is minus 6x plus 8. Now putting x is equal to 3. So therefore f dash of 3 is equal to minus 6 into 3 plus 8, which is equal to minus 18 plus 8. What is minus 18 plus 8? Which is equal to minus 10. So we have proved the required result. Is that clear to all of you? So f dash of 3 is equal to minus 10. So this question is very, very important. So you can copy it. We'll do the next question now. So now we are doing question from HS 2017. So one number 6, this is from the objective question, that is from part B, and each question carries 1 mark only. So if f of x is equal to within mod x plus within mod x minus 1. So first of all you have to simplify this function of x, because within mod there is x, and here also within mod there is x minus 1, that is your second term. Then f of x is continuous at x is equal to 0 and x is equal to 1. Now you have to choose the correct option. Number B is continuous at x is equal to 0 but discontinuous at x is equal to 1. Number C, continuous at x is equal to 1 but discontinuous at x is equal to 0. Or D, none of these. Which is the correct option? You have to check it. Okay. So let us simplify this. F of x is equal to within mod x plus within mod x minus 1. So how will you simplify this function of x? So now त अब हामी यो f of x लाई कसरी सिम्प्लिफाई गर्ने? mod sign हटाउनु पर्छ अनि मात्रै सिम्प्लिफिकेसन गर्न सक्छ. ठीक छ त अब यो हामी कसरी गर्छौं त f of x is equal within mod x and also in the second term within mod there is x minus 1 त यसलाई हामी कसरी सिम्प्लिफाई गर्ने त पहिला यो फर्स्ट टर्ममा within mod के छ x यो x कति बेला 0 हुन्छ if you put x is equal to 0 right so putting x is equal to 0 so what is the value for f of x in this case f of x is equal to within mod 0 plus within mod 0 minus 1 that is f of x within mod 0 means 0 plus this is within mod minus 1 that is f of x is equal to this is plus 1 because within mod minus 1 भनेको थियो 1 नै हो ठीक छ अब फेरि यो सेकेन्ड टर्म within mod there is x minus 1 अब यो x minus 1 कति बेला 0 हुन्छ when you put x is equal to 1 in this case okay if you put x is equal to 1 this second term will be 0 that is neither positive nor negative so putting x is equal to 1 now so putting x is equal to 1 therefore f of x is equal to within mod 1 plus within mod 1 minus 1 or f of x is equal to within mod 1 means 1 plus within mod this is 0 within mod 0 means 0 that is f of x is equal to 1 is that clear so whenever you have x is equal to 0 then f of x is equal to 1 if you have x is equal to 1 then this is f of x is equal to 1 so f of x is equal to 1 when x exactly equal to 0 and x exactly equal to 1 so I think you have understood it okay now let us draw a normal line here let us draw a normal line suppose this is a normal line and here x is equal to 0 suppose x is equal to 0 is out here okay and where does x is equal to 1 lie there is x is equal to 1 x is equal to 1 lie on the right of x is equal to 0 x is equal to 1 will lie on the right of x is equal to 0 this x is equal to 1 lies on the right of x is equal to 0 so this is x is equal to 1 okay so now on the left of x is equal to 0 all the values of x are less than 0 on the right of x is equal to 1 all the values are x greater than 1 and in between this 0 and 1 that is 0 less than x less than 1 isn't it that is on the left of x is equal to 0 all the values of x are less than 0 on the right of x is equal to 1 all the values of x are greater than 1 and between 0 and 1 that is x lies between 0 and 1 okay now we have to simplify this function of x when x less than 0 when x greater than 1 and when 0 less than x less than 1 okay so if x is greater than 1 then f of x is equal to when x is greater than 1 this x is already positive so you don't have to write mod sign so you write only x because x is already positive if x is greater than 1 what can we say about the expression x minus 1 is it positive or negative यो x greater than 1 हुँदाखेरि x minus 1 जहिले पनि positive हुन्छ you can put 2 minus 1 is positive you can put 3 minus 1 is positive so no need of putting that mod sign just write plus within bracket x minus 1 is that clear so you don't have to write mod sign here because x minus 1 is already positive here so which is equal to 2x minus 1 so this is your 2x minus 1 is that clear now if x less than 0 if x is less than 0 that is x is negative now then f of x is equal to now within mod there is x if you write only x it will be negative if x is less than 0 to make it positive you have to multiply by minus sign so it is minus x is that clear so next if x is less than 0 what is the sign of x minus 1 so let us write x minus 1 only out here let us check its sign when x less than 0 यदि यो x less than 0 छ भने x minus 1 positive कि negative हो यदि x less than 0 हो भने x minus 1 positive कि negative x less than 0 भनेको minus 1 हुन सक्छ if you put minus 1 that is your minus 2 negative we are getting negative if you write only x minus 1 we are getting negative but you have to make it positive so you should multiply it by minus sign so let us simplify it you know how to simplify it isn't it minus into minus plus 1 minus 2x minus x is minus 2x So I think you have understood it. Now you have to simplify f of x when x lies within 0 and 1. If 0 less than x less than 1 comma, then f of x is equal to. So this means x is greater than 0. If x is greater than 0, x is already positive. So you have to write only x because it is already positive. So write only x minus 1 first. Let us check its sign. Okay. Is x minus 1 positive or negative when 0 less than x less than 1? When x is less than 1, x 1 banda kamti cha aba. X is less than 1. When x is less than 1, what can we say about x minus 1? Yo x को value चाहिँ 1 भन्दा कम्ती छ भनेको यहाँ के हाल्न सक्छौ तिमीले 0.5. If you put 0.5 minus 1, it will be negative. 0.5 minus 1, it will be negative. That is x minus 1 is negative. If you write only x minus 1, it will be negative. To make it positive, you have to write minus here. So which is equal to x minus x plus 1, which is equal to, this is your 1. Is that clear? Now f of x is equal to 1. F of x is equal to 1 when x exactly equal to 0. Here also we are getting f of x is equal to 1 when 0 less than x less than 1. So here you can write is equal to, because x is equal to 0 हुँदाखेरि f of x is equal to कति छ? That is 1. Again f of x is equal to 1 when x exactly equal to 1. Here also you can put x is equal to 1 because f of x is equal to 1 when x less than or equal to 1. Is it clear now? So now let us redefine this function. Let us redefine this function. Therefore f of x is equal to 2x minus 1. 2x minus 1 when x greater than 1 is equal to 1 minus 2x when x less than 0. 1 minus 2x when x less than 0, right? And f of x exactly equal to 1 when कति बेला हो यो? When 0 less than or equal to x less than or equal to 1. Is that clear now? So this function of x is equal to within mod x plus within mod x minus 1 is simplified here. And we got this simplified expression f of x. This is the redefinition of the function f of x. Okay, so we have redefined this function f of x as this one. Now we can check the continuity and discontinuity at x is equal to 0 and x is equal to 1. Okay, now at x is equal to 0, so at x is equal to, let us check the continuity. For right hand limit, what can you write? Limit x tends to 0 plus f of x is equal to limit x tends to 0 plus. X tends to 0 plus means x is greater than 0. What is the value for f of x when x greater than 0? What is the value for f of x when x greater than 0? X greater than 0 is out here, that is 1. You can write here 1, which is equal to 1 because 1 is constant, right? Now similarly for left hand limit x tends to 0 plus भनेको x is greater than 0, x is greater than 0 यहाँ मात्रै छ. That is your 1. Okay, 1. So this 1 is a constant which is free from x, so its limiting value is always 1. For left hand limit, what can you write? Limit x tends to 0 minus. We are checking at x is equal to 0. 0 minus. This is 0 minus. X tends to 0 minus means x is less than 0. F of x, which is equal to limit x tends to 0 minus means x is less than 0. What is the value for f of x when x less than 0? It is 1 minus 2x. It is 1 minus 2x is equal to, now you can put x tends to 0 minus means x is equal to 0. So you can put x, instead of x you can put 0. 1 minus 2 into 0, which is equal to 1. Right? Now at x is equal to 0. Now at x is equal to 0, therefore f of x is equal to, what is f of x? At x is equal to 0, x is equal to 0, 0 is here. So f of x is equal to 1. So you can put x is equal to 0, f of 0 is equal to 1. So all are equal here, isn't it? That means, therefore, limit x tends to 0 plus f of x is equal to limit x tends to 0 minus f of x, which is equal to f of 0. That is, what can you write here? Therefore, the function f of x is continuous at x is equal to 0. All are 1 out here, right? Therefore, the function f of x is continuous at x is equal to 0. हामीले continuous भनेर प्रुभ गर्यौं, तर at x is equal to 0. बुझ्दैछ सबैले? So you can copy it. So now we will check the continuity at x is equal to 1 now. Understood? Now at x is equal to 1. At x is equal to 1. For right hand limit, limit x tends to 1 plus f of x is equal to limit x tends to 1 plus भनेको x greater than 1. What is the value for f of x when x greater than 1? It is f of x is equal to x minus 1, which is equal, now you can put x is equal to 1. X tends to 1 plus means x is approaching towards 1 from the right hand side. You can put x is equal to 1 here. So 2 into 1 minus 1, which is equal to 1, right? So again at x is equal to 1, you have to find out the left hand limit. For left hand limit, let us write down here. For left hand limit, what can you write? Therefore, limit x tends to 1 minus f of x is equal to limit x tends to 1 minus. So what is the value for f of x when x tends to 1 minus भनेको x is approaching towards 1 from the left hand side, and on the left of x is equal to 1, all the values of x are less than 1. So what is the value for f of x when x less than 1? So when x is less than 1, right? So when x is less than 1, x is less than 1 is out here, 1. So you can write here 1. Since 1 is a constant, you don't have to put the value for x in this case, so its limiting value is always 1, right? So अब हामी केमा लेख्छौं? At x is equal to 1. At x exactly equal to 1. So what is the value for f of x? When x is equal to 1 is out here, f of x is equal to 1. So f of x is equal to 1. So you can put f of 1 is equal to 1. Instead of x you put 1, so f of 1 is equal to 1. Here also all these three are equal. That is, the function f of x is continuous at x is equal to 1. So since limit x tends to 1 plus f of x is equal to limit x tends to 1 minus f of x is equal to f of 1. Therefore, the function f of x is continuous at x is equal to 1. त हामीले यहाँ के देख्यौं? x is equal to 0 मा नि continuous, x is equal to 1 मा नि continuous. भनेपछि कुन चाहिँ करेक्ट अप्सन हो? f of x is continuous at x is equal to 0 and x is equal to 1. So A is correct. Because f of x is continuous at x is equal to 0 and x is equal to 1. So which is the correct option? You should write down here the correct option, which is equal to A. Is that clear to all of you? So this is the answer. So we'll do the next question now. So now we'll do the next question, that is from HS 2020. Yes, पालि पनि आएको छ यस्तो टाइपको क्वेशन, continuity and differentiability, right? But it is an objective type of question. It carries only 1 mark. You have to choose the correct option. F of x is within mod x, where x belongs to the real number. Real number भनेको it is all defined numbers. Real number भनेको x is a defined number. So f of x is within mod x. So f of x is discontinuous and not differentiable at x is equal to 0. Number B, continuous and differentiable at x is equal to 0. Discontinuous and differentiable at x is equal to 0. and number D is continuous and not differentiable at x is equal to 0, you have to check it, which is the correct option. So you can simplify it further. That is f of x is equal to within mod x. So how can you simplify it? Within mod x means x should be always positive. So पहिला हामी के चेक गर्छौं, यो within mod x कति बेला 0 हुन्छ? When you put x is equal to 0. So if x is equal to 0, then f of x is equal to within mod 0, which is equal to 0, which is neither positive nor negative, right? So now if x is greater than 0, then f of x is equal to, when x is greater than 0, x is already positive, so you can write only x. But if x less than 0, then what is the value for f of x? If you write only x, what happens? When x is less than 0, if you write only x, x is negative, isn't it? But you should make it positive. To make it positive, you have to multiply it by minus sign. So if x is negative, and if you multiply it by minus sign, minus to minus is always plus. So if x is less than 0, then what is the value for f of x? It is minus x. Is that clear? So you have to redefine this function. Therefore, f of x is equal to 0 if x is equal to 0. Is equal to x if x greater than 0. Is equal to minus x if x less than 0, right? So हामी पहिला continuity check गरौँ, whether it is continuous or discontinuous at x is equal to 0. So for right hand limit, what can you write? Limit x tends to 0 plus f of x is equal to limit x tends to 0 plus. That is, x is approaching to a 0 from the right hand side, and on the right of x is equal to 0, all the values of x are greater than 0. So when x is greater than 0, what is the value for f of x? When x is greater than 0, what is the value for f of x? It is x. So you can put x is equal to 0, so its value is 0. For left hand limit, what do we write? Limit x tends to 0 minus f of x is equal to limit x tends to 0 minus. X tends to 0 minus means x is approaching to a 0 from the left hand side, and on the left of x is equal to 0, all the values of x are less than 0. So what is the value for f of x when x less than 0? It is minus x. So you can write x is equal to 0, x tends to 0 minus means x is approaching to a 0 from the left hand side. So you can put x is equal to 0 here. So minus 0 हामी कहिले पनि लेख्दैनौं, खाली के लेख्छौं? 0 मात्र लेख्छौं. अब at x is equal to 0. So f of x is equal to what? At x is equal to 0, f of x is equal to 0. Therefore you put x is equal to 0, f of 0 is equal to 0. Now here, since right hand limit is equal to left hand limit is equal to value of the function at x is equal to 0, that is f of 0. Therefore the function f of x is continuous at x is equal to 0. So f of x is continuous at x is equal to 0. Yo continuous भनेर prove भयो. बुझ्यो सबले यो? You can copy it. Now we will check the differentiability of the function at x is equal to 0. Now we will check the differentiability of the function at x is equal to 0, right? So you can copy it. Now अब हामी check गरौँ whether the function f of x is differentiable or not differentiable at x is equal to 0. Okay? The continuous आउँदैछ यहाँ. त कि त b हुनु पर्यो कि त d हुनु पर्यो. a र c चाहिँ हुँदैन, किनभने a र c मा के छ? डिस्कन्टिन्युअस छ. भनेपछि कि त b हुनु पर्यो कि त d हुनु पर्यो. Let us check it. ल अब हामी right hand derivative निकालौं. So for right hand derivative. So what is the meaning of right hand derivative? Capital R f dash of x is equal to limit h tends to 0 plus h tends to 0 plus f of x plus h minus f of x all divided by h, right? So now since we are checking at x is equal to 0, you put x is equal to 0. So putting x is equal to 0, capital R f dash of 0 is equal to, capital R f dash of 0 is equal to limit h tends to 0 plus f of, right, 0 plus h minus f of 0 whole divided by h. Is that clear? So next, what will you do? So now next, therefore capital R f dash of 0 is equal to limit h tends to 0 plus, what is f of 0 plus h? F of h minus f of 0 whole divided by h. So I think you have understood it, okay? So now f of h को value कति हुन्छ अब? So h tends to 0 plus means h is greater than 0. h tends to 0 plus भनेको h is greater than 0. तो h को जग्गामा हामीले x लगायो भने x greater than 0 भयो. x greater than 0 हुँदाखेरि f of x is equal to x भनेपछि f of h is equal to कति हुन्छ? a चाहिँ हुन्छ. बुझ्दैछ? So let us write here, which is equal to limit h tends to 0 plus, what is f of h? It is h. Minus, what is f of 0? When x exactly equal to 0, f of x is equal to 0. That means f of 0 is equal to 0. So this is your 0 divided by h, right? So which is equal to limit h tends to 0 plus h by h. Here h gets cancels, which is equal to 1, isn't it? So it is limit h tends to 0 plus 1, which is equal to 1. So limit h tends to 0 plus 1, 1 is free from h. So 1 is a constant quantity. So you can write down the value of this limit as 1. Okay. So the value of this limit is 1. So this is your right hand derivative. So right hand derivative is equal to 1. So अब हामी के निकाल्छौं? Left hand derivative, right? So for left hand derivative, so now let us check left hand derivative now. Okay, so we have found out the right hand derivative, and right hand derivative is equal to, what was the right hand derivative? Right hand derivative is equal to 1. So let us check this left hand derivative. So capital L f dash of x is equal to limit h tends to 0 minus f of x plus h minus f of x whole divided by h, right? So since we are checking the differentiability at x is equal to 0, you put x is equal to 0 here. L f dash of 0 is equal to limit h tends to 0 minus f of 0 plus h minus f of 0, this whole divided by h, which is equal to limit h tends to 0 minus, this is your f of h minus f of 0, this whole divided by h, right? So h tends to 0 minus भनेको h less than 0 हो. त h less than 0 भन्ने बित्तिकै हामीले x less than 0 मा हेर्छौं. x less than 0 भनेको कति हो? f of x is equal to minus x. त f of h भनेको कति हो? Minus h. If f of x is equal to minus x, you put x is equal to h here, f of h is equal to minus h. So which is equal to limit h tends to 0 minus, so this is your minus h minus, what is f of 0? If x is equal to 0, if x exactly equal to 0, f of x is equal to 0. You can put x is equal to 0 out here. So f of 0 is equal to 0. So 0 divided by h, right? So now which is equal to limit h tends to 0 minus, so this is minus h divided by h, here h gets cancels, which is equal to limit h tends to 0 minus, so it is minus 1, which is equal to minus 1, because limit h tends to 0 minus, minus 1 is there. Minus 1 is a constant quantity which is free from h. यसमा हामी h को भ्यालु हाल्नु पर्दैन, तो यसको भ्यालु नै constant हामीले, that constant will be the limiting value. So what is the value of this limit? Which is equal to minus 1. So are they equal? Is right hand derivative is equal to left hand derivative? No. So the function f of x is not differentiable at x is equal to 0. Since r f dash of 0 not equal to capital L f dash of 0, therefore the function f of x is not differentiable at x is equal to 0. So the function f of x is not differentiable at x is equal to 0. हामीले first part मा के पायौं? The function f of x is continuous at x is equal to 0. But in this case, we got that the function f of x is not differentiable at x is equal to 0. The function f of x is continuous but not differentiable at x is equal to 0. So which is the correct option? It is continuous and not differentiable at x is equal to 0. So this is the correct option, that is number D. So D is the correct option. So I think you have understood it. Okay, so this much is for today. त आज हामीले जति पनि प्रब्लमहरु गर्यौं सबै इम्पोर्टेन्ट हो। त यो इम्पोर्टेन्ट प्रब्लम सबै तिमीले घरमा रिभिजन गर्नु। यो कन्टिन्युटी र डिफरेन्सिएबिलिटीमा हामीले जति पनि प्रब्लम्सहरु गरेका छौं यो सबै तिमीले घरमा राम्रोसँग रिभिजन गर्नु। बुझ्यौ? सजिलै छ, you can understand it. So we have completed continuity and differentiability. So in the next class we'll do the new chapter. Okay, so this much is for today.